Hello everyone, this is Ray Savage with Cambium Networks. Thank you for joining us for today's very special webinar. The webinar is being recorded and it will be available on the community for replay. We should have it posted sometime this afternoon. And during the course of the presentation, if you do have any questions, please use the dialog box on the right-hand side of your screen. Our speakers will be more than glad to take your questions during the course of the presentation. We have a very special group today. We have Arnold Cavazos from Network Tool and Die and Eric Osrelich from WebFormix talking about their experiences with cnPilot. And then Puneet Bhatta, who is our Director of Engineering for cnPilot, will be talking about some of the mesh capabilities of the system. Well, without any further ado, I'd just like to give everybody a quick refresher on cnPilot. And our goal is to have end-to-end affordable, scalable connectivity that's very easy to deploy. Cambium Networks for years has been doing point-to-point backhauls and point-to-point wireless access networks, and the cnPilot products really offer us the Wi-Fi capabilities so that network operators can build an end-to-end solution. Our cnPilot solutions are managed by the cnMaestro Wi-Fi controller and network manager. And this gives you the ability to manage your entire network through the cloud. And the cnPilot Wi-Fi products include the home and small business solutions, the R200 and 201, the enterprise indoor solutions, the hotspot 802.11n solutions, and the E400 solutions. And hang on just a second, let me make sure that we can get the screen back. Okay, hang on just a second. All right. And without any further ado, what I'd like to do is invite some network operators who've deployed the system to be able to share their experiences. And first up is Arnold Cavazos from Network Tool and Die. Arnold?
Thanks, Ray. My name is Arnold Cavazos, and I'm a system and network administrator for Network Tool and Die Company. We operate primarily in Kansas, and we're based in Wichita, and our network base is in Wichita. We're an internet service provider, and we're kind of lucky and unique in the fact that our 100% of our customer base is enterprise or business to business. We've been providing internet service since 2005, and we came from the leased line world, and we found that we could grow our network much faster and for less money, and the money would fall through if we use wireless. So from the very beginning, and mostly out of luck, we chose Cambium/Motorola equipment. I think you can take over the next slide, Ray. And our first two links we put up were a 7-mile PTP 400 Gemini link and a, believe it or not, a 35-mile PTP 600 link. In retrospect, should we have chosen probably any other equipment vendor, especially in 2005, we probably would not be in the wireless business at all. It was just pure luck that that's what we selected out of the options that were available, and we're still doing this stuff. So we started doing multiple tenant unit, multiple dwelling unit infrastructure builds a couple years ago, and it was It was a local developer who was wanting to offer Wi-Fi as an amenity in their apartment settings, and we did that. Started out with a couple, 5, 10 units, apartment structures, a couple 3 access points, and moved up to a little bigger setting. I think our largest one's pushing 70 access points. Natural progression with this same developer was they started moving into the office space realm, and we partnered with them, and we are now delivering what we are calling an Office as a Service product. That Office as a Service product makes it so that we handle 100% of the networking infrastructure. And this particular building we've implemented the E400 in to begin with is, we have space. There's space for about 9 separate offices in this building, and we are handling the Wi-Fi, like I said, the Wi-Fi infrastructure, the wired infrastructure, everything they need to get on the net and do what they do. So we've got some of the customers have IP phones sitting behind these things, and we can do basic firewall, advanced firewall, and including remote VPN for people who are not locally within that building. It's up to us to make sure that the network is secure, and each tenant's network is partitioned from each other. So that leads us on to the next slide. Like I said, 9 office spaces and 2 conference rooms. There's 3 floors worth of building in this structure. The exterior of the building is stucco over concrete, and there's a lot of glass. It's in the middle of downtown Wichita. We're about 280, 300,000 in the city, and the Metroplex is probably around 400,000. It's a pretty tough RF environment. That's just all there is to it. Noise floor is pretty high, and so we need to make sure that our gear is well placed. And the building is the interior of the building is metal stud and 5/8 inch rock on each side. So we decided to, especially considering where the glass is, and you lose -3 dB from everything outside through the glass, so the noise floor is high. So we put the APs in the center of the building, and we're just running the highest allowable limits for the 2.4 and 5/8 that we can do. So what we're doing, instead of allowing these tenants to turn up their own Wi-Fi, we're providing it. So that allows us to make sure that we don't have to coordinate RF channels within the building with anybody else, and so we are the sole RF emitter. It's kind of hard to see in the drawing, but what we're doing is we're using a concept, we're calling it Wi-Fi on a stick. It's the flip side of router on a stick. The E400 allows us to have 16 disparate SSIDs. So each tenant in the building is getting their own SSID, and we're assigning a separate VLAN to that SSID, and we're trunking the E400 back to a managed Ethernet switch via 802.1q trunks. And then we are busting out the LAN segments to the customer, sometimes in a switch, sometimes in just a port, depending on how big the customer is. But it's allowing us to turn up a single 20 megahertz channel on the 2 gig just for backward support, and we're actually doing 80 megahertz channels in 5. So far that's worked out great. I know that's kind of a pipe dream, doing 80 megahertz in AC, but it's working for us so far. Maybe quite a bit attributable to the fact that we're the only RF emitter within the building. Next slide, Ray. So here is an example. Okay, so we lit this building with a gigabit Ethernet link, a full duplex gigabit Ethernet. So we, we have the ability to put the E400 through its paces. Spectrum is, as you can see, a neat thing about this E400 is you can do spectral analysis live on the network without dropping people. It's a pretty neat little trick. I think my understanding is you may drop a few frames here and there, but nobody ever loses connectivity. So, we're seeing in the 2.4 gig range, we're seeing noise floors pretty high, negative 50s, negative 40s. It's a big deal. So this E400, this is a real-world test from us out to the world across the internet pipe, and we're doing 150 by 80 real throughput through this device while there's other people working on it. This wasn't an off-hours test. This is while everybody's getting their day on. So do I have one more slide or am I done? No. Okay, here we go. We tend to enjoy configuring our equipment on CLI just to make sure we don't mind our P's and Q's and we have apply consistent config. cnPilot / this E400 allows us a lot of manageability. We're happy with the web interface for configuration and monitoring and spec analysis, but I can fully configure an AP from the CLI. I don't have to have a controller. I don't have to make it log into a controller to do that. Now I can if I want. I just haven't explored that. We haven't explored those possibilities yet, and I'm sure that will help us in the future. You can export and import configs via TFTP and FTP. That makes onboarding for us very, very convenient. We can generate a flat file config and pull it in, and we know that we've got the same baseline across the board. And all this while, we can jump in via cnMaestro from anywhere, and let us see what's going on. It doesn't matter whether it's behind NAT, it doesn't matter whether it's behind any sort of stateful packet inspection firewalls. As long as it is allowed out to get back to the cloud, cnMaestro can give us quite a bit of information. So green light, red light, just from a customer calling in or something like that, and perhaps we're not in the field instead of at our desk, we get to see exactly what's going on quickly and know whether, what we need to do to react. Cambium support has been very good. Puneet has been able to help us with some questions that have gotten pushed over to him, and we've gotten a lot of nice responsive situations from that. The dashboard in the GUI is great. I don't know where else we can get 802.11 AC access points, dual band, that's capable of doing 16 WLANs for 199 MSRP. That's just that's a game changer as far as we're concerned. Most all the other price comparative access points can do 4, and that's great if that's all you need. But we found the need to jump way through the 4, and we're very happy. We haven't had to do any debugging yet. Play with CLI and the debugging aspects of it, mostly out of curiosity. But you can get a lot of information out of those access points, whether it's from the test and turn-up phase of bringing a customer on board or actual troubleshooting after the fact. So thank you very much for allowing me to speak.
Thank you, Arnold. I'm sure folks may have some questions as we go through. Right now, what I'd like to do, the thing that I found fascinating was how much throughput you're able to pump into that building where you have a confined building and you kind of own all the RF inside. Our next case study that we'll look at is by WebFormix. And this is one that's a multi-dwelling unit. It's not a business. and I'm sure that Eric Ozrelik will be able to help us understand exactly how he went through the network design and implementation. Eric?
Hey, thank you, Ray. Good morning. Hi, I'm Eric Ozrelik with WebFormix. And yeah, as a double bonus this morning, I'm actually doing this webinar from my house, which is over a 1.5 mile non-line of sight PMP 450i 900 megahertz link. And then I have, I'm connected to an E400 in the house right now. So we'll see how this goes. And it's raining. So first slide, please, Ray. So Eagle Landing is kind of came to us, fell in our lap. It was quite the mess. They have 150 apartments spread over a large campus. The residents have access to DSL cable and Wi-Fi. When we got there, they just had this mix of this other consulting firm had put in all these ingenious 802.11g access points, and they were kind of just draped all over the place. There was no real way to manage it or tell when one of the APs went down. It was all reaction based. You know, people would complain about something, and they would call up the property management company, and then they in turn would call up this other consulting firm, and the consulting firm had was charging these people quite a bit of money to not only manage the network in this style, but also for the bandwidth. And basically the property management company was just tired of it, and they were getting ready to throw in the towel on this whole project. And then we caught wind of it and thought that maybe that we could make some changes and make this a viable project and venture. Next slide. So I apologize for the wall of text here. I kind of, this pretty much covers all of it, and I wanted other people to be able to look at this later on. So I'm just going to kind of gloss over it. But we had some requirements for this. Obviously, what was in place was just not working. So we wanted to do it right from the get-go, and we had a list of requirements that we needed in a radio and system that we wanted to deploy out at Eagle Landing. So Andrew, I believe, kind of mentioned there's some overlap here. Sounds like we kind of had some of the same goals here. We wanted an intelligent dual band 2.4 or 5 gig radio, needed to support PoE, needed to have small enough footprint to fit in these enclosures that we were using, and you'll see a picture of the enclosure here in the next slide. But at this point, I think that there's enough clients that are using 5 gigahertz and have some AC devices to really take advantage of a dual band radio, especially with the 2.4 RF environment being as difficult as it is. Another thing that we really wanted was the flexibility to allow for individual radios to be configured by hand. So if we just wanted to, bust out a radio out of the box, put it on the bench, plug an Ethernet cable in and log in via an IP and configure it via web or CLI, we had that option. Or use some of the zero-touch configuration options where we could just onboard it to the cloud and push out a configuration. We've dealt with some other brands of radios in the past where you can literally not configure them unless they're connected to a cloud. So we wanted that option to be able to go back and forth, maybe a smaller install or an area that doesn't have cloud access. We wanted to have that versatility. And then we want radios that could handle being behind NAT. So this site, again, it's a large campus. We only had one internet connection there, and due to public IP addresses being almost impossible to get these days, the entire complex is behind NAT. So we had to get a radio that would be able to traverse NAT and contact the cloud. We will need access to dynamic VLANs in the future. Basically, we just needed the radio to support a number of different networking topologies and scenarios. And then lastly, we wanted a radio that could scale well and had good power output and had good MIMO features. And let's see, I'm just along with providing management and monitoring for backup. Okay, so we also wanted a cloud system or a back-end system that would also handle other devices along with the APs. So in the future, if we want to add a backhaul or a P2P link or something that was part of this system out at Eagle Landing, we could add that to the dashboard cloud controller. So next slide, please. So another wall of text, I apologize. We got an E400, a couple of E400s, and cnMaestro was in beta. We took them to our office, and we'd start doing some testing based upon the criteria that I outlined in the last slide. Does the radio propagate well and work with a variety of 2.4 and 5 gig? Yes. Can the radio be configured standalone via the radio's UI? Check. Can it be zero-touch onboarded? Check. All these items we went through and found that the E400 and cnMaestro fit the bill for all these requirements. One thing that they're getting close on is the can we add other Cambium devices like ePMP and PMP450 and P2P products. They're getting there. They have ePMP is mostly supported today. PMP450 and other products are next up. They're supposed to add support for them this year in cnMaestro. And then yeah, can we roll out different configurations and firmware updates to one or more radios managed? So yeah, you can do that. You want to roll out one type of configuration, half the radios, and another type to the other half. You can do that. You can even set variables that will increment. Like if you want to have set the IP address to a static IP on each radio, and you have 20 radios, you can set that to increment as it's deployed to each radio. So again, there's some powerful templating and configuration features there. They're just going to get better and better as they fine-tune cnMaestro. Let's see. Oh yeah, so here's the deployment. Thought I'd give you a little bit of some pictures instead of a wall of text. I think the single biggest advantage that I can tout for the E400 and cnMaestro was the ability to take the E400 out of the box, look at the serial number, go to the cloud, add the serial number on the onboarding process, and then just put the radio up on the wall and plug it in. And what we found was that when we did some time tests, the previous method used to be unbox, we'd update the firmware on the radio, we would hand type in the configuration either via the GUI or the CLI, and that would take approximately 15 minutes per unit. With the new method where we unbox, add serial number to cnMaestro, and we pushed out a config via the cloud, it's approximately 5 minutes per unit. And if you have a large campus deployment, like we did with 70 some odd radios, the total time savings for this project are 10 hours. That's 10 hours of time not spending with manpower, with people you know, pushing, manually typing in configs or updating firmware. So that's a huge savings. Next slide. We also had some great opportunities to use some of the additional advanced control features of the E400 and cnMaestro system. As I mentioned before, we were using, the previous consulting firm was using all these ingenious APs. These ingenious APs were dumb APs. They really didn't have much in the way of settings or controls. And so because of that, they had people that were abusing the system, people that would do BitTorrents or other forms of traffic that would monopolize the AP and the network. And one very handy feature that the E400 support is the ability to set a rate limit per client and a rate limit per LAN. And this is great because it keeps people from completely saturating an AP. So they could be doing torrents, maybe they have a virus, who knows what it is, but they can only push a maximum amount of data upstream and downstream from, and this is controlled on the AP. So it's right at the edge of the network. The traffic doesn't have to get all the way back to a central controller in order to be rate limited or to be restricted. So we use this feature extensively, and we found that it's cut down on quite a bit of complaints and just makes everything smoother for everyone accessing the APs. Makes it a lot more fair. And then we got the intelligent channel selection and enhanced roaming. I think Andrew kind of went over this a little bit, but this is a great feature. Kind of gives you an idea of what's out there on your APs. And we use this in conjunction with the automatic channel selection, which is another great feature that allows for the E400 to, based on certain criteria, automatically pick the best channel, and it uses this spectrum analysis in order to do that. Don't have control over the RF landscape, and maybe other people have various devices, Wi-Fi devices. This is kind of a joke. The ingenious 802.11g on the left, that's before what kind of net throughput they would get. You know, about 14 megabits on the downlink and you know, 17 on the uplink. And you could imagine having 2 or 3, 4 people access that AP, and it would get really congested very quickly. The E400 is on the right, and that's a 5 gigahertz AC link, and you can see down there there's a MikroTik bandwidth test. It's showing 234 megabits on a, I want to say that's a TCP test, but yeah, there's no comparison. It just rocks as a radio. Lots of throughput. So yeah, that's that. So thank you very much for your time.
Thank you, Eric. Eric, it's really great to see the system get deployed so quickly and perform so well. It's really been a game changer for you. Well, let's shift gears a little bit and take a look at wireless mesh capabilities. Leading us in the discussion today is Puneet Bhatta, who is the Director of Engineering. Puneet?
Hi, Ray, thank you. So we'll go over wireless mesh, which is a feature that we are adding to an upcoming release on the cnPilot E400 and the EPMP 1000 hotspot. This feature will be part of our 2.0 release, which will be in beta in February and released towards the end of Q1. What we are adding is support for 2 access points to bridge traffic wirelessly between them. And the way you would set this up is one of the access points would be configured as a mesh base. So this would be the AP that has connectivity to the wired network. and as soon as this AP powers up and reads its configuration, it would start beaconing, the radio would be operational. And another AP would be set up as a mesh client. So this is the other end of the wireless hop, which does not have wired connectivity. The mesh client AP's radio would come up, scan for mesh bases on all the operating channels. And once it finds an appropriate base, it would connect to it, and we would start bridging traffic out onto the wired network through the base. The link that the access point form among themselves is secured, so it's a WPA2 pre-shared key based link, and each base AP can support up to 5 different client access points. So you can have a star topology on your network. You can have 2 or 3 bases connecting, 2 or 3 clients connecting back to one base bridge. The typical use cases for this, so we see 3. There could be more as we go out and we get feedback from customers. So the first one is to provide Wi-Fi access in areas where there is no cable run. We have seen cases where you might have a certain part of the building where it's difficult to draw an Ethernet cable, but you still want to provide wireless access there. With the wireless mesh feature, you'll now be able to do it by installing a client AP and having that AP connect back to a base access point. The client AP, if it's a single radio access point, can do both. It can service clients as well as connect back onto a base. If it's a dual radio, you have a choice of either dedicating one radio for clients and one radio for the mesh backhaul, or you can have the 5 gig radio do both the things, or the 2.4 service clients as well as act as the backhaul. Another use case would be to extend range outdoors. So the mesh capability is we don't require both the access points to be of the same type. So you can form a mesh link between an EPMP 1000 hotspot and a cnPilot E400, for instance. So we have seen cases where a building is being serviced by cnPilot E400 APs indoors, and then the customer wants to have access out in the parking lot. And you can now do that by installing the EPMP 1000 hotspot and having it connect back wirelessly into the building. And at the same time, it can service clients out in the parking lot. Another use case is to plug coverage holes. So there may be instances where you have good coverage in most areas of your building or of your campus, but there's one particular facility where it would be useful to have another access point. And again, cable run might be an issue there. So now you can easily extend the coverage by installing another access point, having one of its radios configured for the mesh client, and it can provide Wi-Fi access to wireless clients and connect back to your main network wirelessly and bridge traffic through that. So there are a couple of cautions and caveats as you're configuring mesh, things to keep in mind. We are supporting only single hop, so you cannot daisy chain multiple bases and clients. And there is one good reason for that, and that is the throughput drop. So the mesh client would receive packets from a base, and then it would have to transmit them back again onto other devices. And this results in almost half the throughput being lost with every hop on the network. So the moment you start going to 2 and 3 hops, the amount of throughput that remains, it goes down to very low levels. The base and the client would also operate on the same channel, since they need to maintain connectivity to each other. So this would also affect your channel distribution at the site and cause more co-channel interference. The APs have to be pre-provisioned before installed, so you cannot plug an AP out of the box and have it connect back to the base network. You do need to log on to the access point, configure the SSID that you're using for the mesh link, configure any security parameters. This is something that we are looking to enhance in the future, where we'll have an option to have an out-of-the-box connectivity. But for now, in this release, when you bring up the access point, you configure the SSID, configure the security, and then power it up, and the client would then connect back to the base. Of the 2 radios on access points such as the E400, only one of the radios can be configured for mesh, so either the 2.4 or the 5 gig radio. And lastly, the mesh link does use one SSID. So of the effective number of wireless LANs that you have on the radio, we would end up using one, and you would reduce the total available SSIDs. So on an EPMP 1000 hotspot of the 8, you would have 7 available for clients, and on the E400 of the 16 you would have 15 SSIDs available for client access. As far as configuration goes, we're trying to keep it very simple. Since this is based on wireless LAN, you would configure the mesh also on the wireless LAN page. When you go to edit the first wireless LAN on your GUI, we have a new option there that indicates mesh, and the default is off, but you can change this to be a mesh base or a mesh client. The moment you choose any of the mesh options, most of the other wireless LAN configuration items are grayed out. The only options that will be available are security and the radios. And if the security is changed to WPA to PSK, in this case it's open, but let's say you had WPA to PSK, you would also be able to configure the passphrase. So it's just a couple of configuration items. Configure the SSID. You have one of your radios configured with a base WLAN, one of the radios configured as a client WLAN, and the mesh link would form automatically. Yeah, that's pretty much it on configuration. In terms of statistics, I don't have a screenshot here, but we do have a dashboard that shows you the mesh link that has formed and the quality of the mesh link between the base and the client AP.
Excellent. Thank you, Puneet. And I'm sure we'll have more on that and some field stories on that as soon as the products get out to the field. Well, obviously, for everybody, there's a lot of news on cnPilot. So we'd encourage you to follow us on social media. We're on Facebook, LinkedIn, Twitter, Google+, and Weibo. And the best place to find information is the community, and that's at community.cambiumnetworks.com. Costs nothing to join. It's all free. And there you'll find discussion forums on our products, including cnPilot and cnMaestro. Tips on network planning, also business issues. There's a knowledge base with certified information from our technical support team. And a lot of the things that we do are really built around ideas that have been submitted by customers. And so we'd encourage you to take a look at that ideas section, submit an idea, or vote for one that you think is very important. And just as we've had here with Arnold and with Eric, it's always important to learn from each other. And we have a whole section of the community there called Your Stories, where network operators can post their experiences, and anybody is welcome to answer questions and interact with those network operators around the world. Puneet, we did have one question that just came in on the line. What is the effective distance that can be covered in mesh? And I know obviously it depends is the answer based on physics. But what would be a good rule of thumb in terms of square feet?
Today we are still carrying out tests on this, and I'll have numbers that we can share in terms of the throughput numbers that we are getting at different range values over the next couple of weeks. But in general, for the EPMP 1000 hotspot, for instance, we have a range of about 600 feet. And we are seeing the mesh link being able to maintain connectivity over that. The throughput goes down a lot, so we'll have numbers that we'll publish for throughput and range over the mesh link.
Great, thank you. And we did have a question about the recording of the webinar, and it will be available on the community for replay. We also put it up on our YouTube channel as well, and those should be up there this afternoon. Let's see. Here's one, Puneet, that you might be able to handle. Here's a network operator who asks, if I have a network connection to each of my E400 access points, do you have any links with resources that can help me to do the configuration of that network? I'd like to have them working together with the same SSID if possible. Puneet, are you there? You might still be on mute.
Yeah, I was on.
Okay.
Yeah, so just so I understand, we have two access points. Both of them have wired connectivity, and we want to
Yes.
configure them with a similar configuration, the same
Yes.
SSID and security profile. Yeah, so we can do that today. cnMaestro is a good way to push configuration to multiple access points. You can create one config template. The config template can have some variables customized. So let's say you want the static IP to be different, but the rest of your wireless LAN parameters are the same. So you can create one template, and that same template can be pushed to more than one access point at the same time. So
Okay.
all that we would need to do is onboard the APs into cnMaestro.
Okay, and then to find, I guess, more information on cnMaestro, certainly you can go to the community if you go there and search on that. I know in the knowledge base we have some how-to videos on cnMaestro there. I think configuration is one of them.
Yes, configuration is covered in one of the videos. We have also included some sample templates now in the newer version of cnMaestro.
Excellent.
So to help you get started, there are some example templates for configuration.
Thank you very much, Puneet. Well, those are all the questions that we have in the queue. I'd like to say a special thank you to Arnold Cavazos and Eric Ozrelik for sharing their information. And Puneet, thank you. We look forward to hearing from you as we continue to evolve cnPilot. Thanks, everybody. We look forward to seeing you on the community or at a future webinar. Have a good day.